Good morning, dear students. I am Ramdas. I welcome you to my channel Maths from Basics for you. In the earlier class, I have done important formula for differentiation, then trigonometric ratios, and now I am going to start with trigonometric identities. So, in the event, if you are good in important formula for differentiation, trigonometric ratios and trigonometric identities, the base is set for you to start differentiation. So with this setup, in the event if you are good in all this, definitely I'll make maths easy for you, otherwise it will be difficult. So I want you to follow my classes regularly. Let's start differentiation, that is trigonometric identities. Now for that I need, yes, I forgot to tell you about my funda. My funda is learn maths from basics, and I'm there to teach you mathematics right from basics. So without much of our time, we shall start with trigonometric identities. For this, I require a right angle triangle, and I have marked this right angle triangle as ABC. So in the previous class, I have explained to you about theta and all those things. I know you are familiar with what is sin theta, cos theta, tan theta, etc. So with this knowledge, let us start trigonometric identities. So now we all have studied Pythagoras theorem in 10th standard. See, we cannot forget Pythagoras theorem because its application is here to find out the trigonometric identities. So what is Pythagoras theorem? If you have forgotten, I'll remind you. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the opposite two sides. That is, if I call this as opposite side, and this is adjacent side, and this is our hypotenuse. So what Pythagoras theorem says is the square on the hypotenuse is equal to the sum of the squares of the other two sides. That is AB square plus BC square equals to AC square. That is our Pythagoras theorem. In order to respect that gentleman, let us write what is Pythagoras theorem. So Pythagoras theorem let us know what it is. So in a right angle triangle, the square on hypotenuse is equal to the sum of the squares of the opposite two sides. So Pythagoras theorem states that in the right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the opposite two sides. That is AC square equals to AB square plus BC square. So it states that the square on the hypotenuse, that is AC square, is equals to AB square plus BC square. So that is Pythagoras theorem. With this, we will try to find out the other trigonometric identities, which is very important for differentiation. If you are sound in important formula for differentiation like trigonometric ratios and this one, you are fully set to handle any sort of problems on differentiation, and it is my responsibility to see that you are good in differentiation. So let's start. I'll rub this. So if you want to make a note of this, please make a note. We shall start now. Let me call this opposite side. Okay. Now, by Pythagoras theorem, we have AB square plus BC square equals to AC square. So I call this as equation 1. So I call this Pythagoras theorem as equation 1. What I will do is, I will divide this equation throughout by AB square. So, by dividing equation 1 throughout by AB square, we get what happens? I divide this equation throughout by AB square. So that is AB square by AB square plus BC square by AB square equals to AC square by AB square. Now, I will abbreviate this as hypotenuse, opposite side, and this is adjacent side. Okay. So please recall my previous class wherein I had said what is sin theta. Sin theta is opposite side by hypotenuse, that is opposite side by hypotenuse. Then cos theta is adjacent side by hypotenuse, right? Tan theta is opposite side by, that is tan theta is sin theta by cos theta. So if you divide one by the other, so hypotenuse cancels, we are left with opposite side by adjacent side, that is opposite side by adjacent side. So opposite side by adjacent side, cot theta is the reciprocal of tan, or that is if you divide cos theta by sin theta, we get cot theta, that is adjacent side by opposite side. This is your tan theta. Now secant theta is reciprocal of this, that is hypotenuse by AS, and cosecant theta is equals to the reciprocal of sin theta, that is H by OS. So this is an important relation we shouldn't forget. Now, what is AB by AB square by AB square? That is nothing but 1 plus. What is BC? BC is adjacent side. What is AB? AB is opposite side. And square equals to what is AC? AC is hypotenuse. What is AB? AB is opposite side, and here is square. So 1 plus, what is AS by OS? AS by OS is cot theta is AS by OS, that is cot square theta equals to, this is H by OS. H by OS is cosecant theta, that is cosecant square theta. So this is an important relation which you should know. So this is our important relation, equation 2. What I'll do is, I'll try to shift this one to the right hand side. So this is our LHS and this is RHS. I shift cot square theta to the, I shift one to the right hand side. That happens, that is cot square theta equals to cosecant square theta minus 1. So this is another important relation which you should know. I call this as equation 3. So equation 3. Please make a note. Now what I'll do is, I'll keep this one on the left hand side and transfer this cot square theta on the right hand side. So one is, that is 1 equals to cosecant square theta minus cot square theta. This is another relation. So what I'll do is, I rewrite this. Instead of keeping the one on the left hand side, I'll try to transfer left hand side to right hand side and right hand side to the left hand side. So I'll rub this, So what I'll do is, I rewrite this, that is cosecant square theta minus cot square theta equals to 1. This is our equation 4. So I have rewritten this. Instead of keeping this one on the left hand side, I have transferred one to the right hand side, made cosecant square theta minus cot square theta equals to 1. So please make a note. I will rewrite all this. First one is what? 1 plus cot square theta equals to cosecant square theta. I have taken this, cot square theta equals to, next cot square theta equals to cosecant square theta minus 1. So I am rewriting this. Third one is this cosecant square theta minus cot square theta equals to 1. So please make a note of this. I need this space, so I'll rub this. I'll write it small. Opposite side, that is opposite side. So this is, I'll write this, that is secant theta is reciprocal of cosine, that is h by as. So I'll rub this, please make a note. Now, this is our Pythagoras theorem. In the earlier case, we have divided this Pythagoras theorem throughout by AB square. Now, what I will do is, I will divide this equation, I will divide this equation 1 throughout by BC square. Instead of AB square, I will divide this time by BC square. So, that is, I will write by dividing equation 1 throughout by BC square. So that is AB square by BC square plus BC square by BC square equals to AC square by BC square. Now what is AB? AB is nothing but OS, that is OS by BC. BC is AS square plus this BC square by BC square equals 1 equals to, what is AC? AC is H, hypotenuse, divided by BC is adjacent side square. So, what is OS by AS? OS by AS is tan theta, that is, we have a square, so it becomes tan square theta plus 1 equals to, what is H by AS? H by AS is secant theta. So it becomes secant square theta. So this is equation 5. So this is an important relation which you need to remember. Tan square theta plus 1 is equals to secant square theta. So what I will do, I rewrite this. Usually we always write this in this form, that is 1 plus tan square theta equals to secant square theta. This is the way we write this formula. So remember this, an important. 1 plus tan square theta equals to secant square theta. So fourth is 1 plus tan square theta equals to secant square theta. So what I will do here, I will keep this tan square theta on the left hand side and transfer this one to the other side. So fifth one is tan square theta equals to secant square theta minus 1. This is also important relation, that is tan square theta equals to secant square theta minus 1. This is also an important relation, you should remember. And what I'll do is, I'll keep this, I'll rub this. What I'll do is, I'll keep this 1 on the left hand side and transfer this to the right hand side. So 1 equals to, that is secant square theta minus tan square theta. So I'll rewrite this as secant square theta minus tan square theta equals to 1. This is also an important formula. Let us make it sixth. Secant square theta minus tan square theta equals to 1. Know this formula is very important. So I'll rub this. So we have got 6 relations. Let us see 3 more relations. Now I'll rub this too. Now, in the earlier case, we have divided this equation, this Pythagoras theorem, first by AB square, then second time we have divided this by BC square. Now let us see, we will divide it by AC square throughout. Let us see what happens. By dividing equation 1 throughout by AC square. What happens? That is AB square by, that is, I'll write like this, that is AB square plus again BC by AC square equals to AC by AC square. Now let us see what is AB by AC. AB is opposite side, AC is hypotenuse, and this is square, plus what is BC? BC is adjacent side by H, and this becomes 1. Now what is OS by H? OS by H is sin theta, so it is square now. This becomes sin square theta plus what is AS by H? Adjacent side. So I'll rub this. What is AS? Now we are left with what? Cos theta. What is cos theta? Adjacent side. Adjacent side by hypotenuse. So by H is cos theta, that is cos square theta equals to 1. So this is very important relation. Sin square theta plus cos square theta equals to 1. So we'll rub this. Seventh one, sin square theta plus cos square theta equals to 1. So I'll keep this sin square theta on the left hand side, transfer this cos square theta on the other side. That is sin square theta equals to 1 minus cos square theta. This is another relation. So 8th one is sin square theta equals to 1 minus cos square theta. So I'll rub this, please make a note. I'll rub this. Now this time what I'll do, I'll keep cos square theta on the left hand side and transfer sin square to the other side. So cos square theta I'll keep now, this becomes 1 minus sin square theta. So 9th one is cos square theta equals to 1 minus sin square theta. So these are important relations which you should remember. Remember this relation is very important for you, and if you are thorough with trigonometric important formula for differentiation, then trigonometric ratios and trigonometric identities. If you are thorough with this, differentiation will be easy for you. So I end this trigonometric identities here, and we'll try to do some problems on functions. First of all, let us try to know what is functions and what happens with different types of functions. We'll try to differentiate some functions and find out what happens to that. So with this note, I end here. I request to like my video, share my video, and subscribe to my channel. It's very important so that others also have the privilege of watching my TV. So with this note, I end here. So good day, students, and thanks for watching me. God bless you.